Boeing's next-generation air dominance NGAD demonstrator has achieved a remarkable milestone, moving from contract award to its first flight in less than 2 years. This swift progress is reminiscent of the timeline seen with the B-21 Raider, a development that has garnered attention for its innovative approach to military aviation. Analysts are optimistic that the forthcoming engineering manufacturing development EMD F-47 and F/AXX aircraft will not merely serve as prototypes but will instead be highly representative of the production models intended for operational deployment. This evolving landscape in military aviation emphasizes the importance of integrating rigorous production processes into the development cycle. The first B-21 test article, for instance, was constructed using the same manufacturing line and tooling that will be employed for the entire fleet. This commitment to quality and readiness is a significant departure from the traditional prototype model, which often involves a more experimental approach. The B-21's design includes its primary mission systems from the outset, ensuring that operational capabilities are prioritized throughout the development process. Looking ahead, the timelines for the F-47 and F/AXX programs appear promising. Analysts suggest that provided there are no significant delays or protests, the timeline from contract award to the rollout of these aircraft could be completed in less than 3 years. This rapid pace of development is indicative of a broader trend within military aviation, where efficiency and speed in production and testing are becoming increasingly critical. The integration of insights from various sources underscores a shared narrative of accelerated development and production readiness in modern military aircraft programs. Both the NGAD demonstrator and the B-21 Raider are being designed with a focus on operational capability, aiming to meet the demands of contemporary warfare. This shift in approach reflects a growing recognition among defense contractors of the need to deliver operationally relevant systems in a compressed timeframe, ultimately reshaping the landscape of military airpower in the coming years. In summary, Boeing's advancements with the NGAD demonstrator alongside the B-21 Raider's development signal a new era in military aviation, characterized by rapid innovation and an emphasis on production readiness. As the F-47 and F/AXX programs move forward, the implications of these developments will likely influence military strategy and capabilities on a global scale. The commitment to building operationally relevant aircraft from the outset sets a new standard for defense projects, paving the way for enhanced air superiority in modern combat scenarios. The content highlights several counterintuitive aspects related to the development of Boeing's next-generation air dominance NGAD demonstrator and its implications for future military aircraft programs. 1. Rapid development cycle. It may seem counterintuitive that a complex military aircraft can transition from contract award to first flight in under 2 years. Traditionally, military aircraft development has been associated with lengthy timelines due to extensive testing and prototyping phases. The success of the NGAD demonstrator and the B-21 Raider challenges the perception that such rapid development is unattainable in the defense sector. 2. Prototypes versus production representativeness. There is a common belief that prototypes must inherently differ significantly from production models, often serving as testing grounds for new technologies. However, the assertion that the EMD F-47 and F/AXX will be highly production representative rather than mere prototypes indicates a shift in strategy. This suggests that future aircraft may be designed with operational capabilities in mind from the outset, which goes against the traditional view that prototypes are primarily experimental. 3. Emphasis on operational capability. The idea that early test articles such as the B-21 will include primary mission systems and be built using the same manufacturing processes as the final fleet is notable. This contrasts with the past, where initial test articles often lacked full operational capabilities. The commitment to integrating these systems early in the development process may enhance readiness and operational effectiveness, which runs counter to the typical phased approach seen in military aircraft development. For efficient manufacturing processes, the notion that defense contractors can utilize the same tooling and manufacturing lines for both prototypes and production aircraft suggests a level of efficiency that is often not associated with military procurement. It challenges the conventional wisdom that military projects must be excessively bureaucratic and slow-moving, indicating a potential for modernization in defense manufacturing practices. 5. Timeline expectations. The forecast that the F-47 and F/AXX could roll out in less than 3 years from contract award, assuming no protests or delays, contrasts sharply with historical timelines for military aircraft development, which often extend over a decade. This optimism reflects a significant paradigm shift in expectations around military aviation projects, suggesting that the industry can achieve much faster turnaround times than previously thought feasible. 6. Potential impact on military strategy. The rapid development and production readiness of next-generation aircraft could lead to a re-evaluation of military strategies and operational planning. If these aircraft can be deployed more quickly and are more capable than their predecessors, it suggests a future where air dominance could be achieved with less lead time, fundamentally altering the dynamics of military engagements. These counterintuitive elements highlight a transformative period in military aviation development, suggesting that defense contractors like Boeing are adapting to new technologies and methodologies that enable faster and more efficient aircraft production. The implications of this shift extend beyond the aircraft themselves, potentially influencing military strategy and operational readiness in profound ways. Boeing's rapid progression from the contract award to the first flight of its next-generation air dominance NGAD demonstrator in under 2 years is a noteworthy development in military aviation that warrants closer examination. While many may focus on the speed of this process, several underlying aspects are significant yet often overlooked. Here are the critical points that deserve further exploration. 1. Production readiness versus prototyping. The distinction between prototypes and production representative models is pivotal in understanding the implications of the NGAD program and its counterparts, such as the B-21 Raider. Analysts suggest that the engineering manufacturing development EMD aircraft F-47 and F/AXX will be built as highly representative of production models rather than mere experimental prototypes. Significance: this shift indicates a paradigm change in military aircraft development. Historically, prototypes served primarily as testbeds for technologies and concepts, often resulting in lengthy iterations before reaching operational status. In contrast, focusing on production representative models accelerates the timeline to operational deployment and enhances the likelihood of fielding systems that meet real-world operational requirements from the outset. This could have far-reaching implications for military readiness and response times. 2. Manufacturing processes and quality assurance. The construction of the B-21 test article using rigorous production processes and the same manufacturing line and tooling intended for the broader fleet is a notable detail. This practice is unique to development programs and marks a departure from conventional approaches. Significance: by integrating quality assurance and production methodologies early in the development process, Boeing is not only ensuring that the first units are combat-ready but also setting a benchmark for future defense manufacturing. Such an approach minimizes risks associated with late-stage modifications and reduces the time needed for operational testing and validation, ultimately leading to a more reliable defense apparatus. 3. Operational capabilities from the outset. The inclusion of primary mission systems in the B-21's first test article underscores a focus on operational capabilities from the very beginning of the development cycle. This is a critical factor that can often be overlooked in discussions about military aircraft. Significance: by embedding mission systems early on, the aircraft can undergo realistic testing that evaluates its performance in scenarios it will face in actual operations. This contrasts with traditional models where mission systems might be added after initial flight tests, potentially leading to unforeseen complications or integration challenges later in the process. The proactive approach taken by Boeing could enhance the effectiveness and reliability of these platforms in combat situations. 4. Accelerated timelines and implications for future programs. The forecast of a timeline of less than 3 years from contract award to the rollout of the F-47 and F/A-XX, assuming no significant delays or protests, is an ambitious goal that reflects broader trends in military innovation. Significance: this acceleration could fundamentally reshape military airpower strategies, allowing for quicker integration of advanced capabilities into the fleet. The ability to rapidly develop and deploy new aircraft could provide a strategic advantage in a rapidly evolving geopolitical landscape where technological superiority is increasingly linked to military effectiveness. It may also encourage other defense contractors to adopt similar methodologies, fostering a culture of speed and efficiency across the industry. 5. Potential challenges and risks. While the advancements in timelines and production methodologies are promising, the report hints at potential challenges, particularly concerning protests or delays that could arise in the procurement process. Significance: understanding the risks associated with such accelerated timelines is essential. If protests or legal challenges arise, they could significantly delay the rollout of these critical systems. Moreover, the rushed nature of development could inadvertently lead to oversights in quality control or operational testing, compromising the integrity of the aircraft. The balance between speed and thoroughness is a delicate one that military planners must manage carefully. Conclusion: the advancements in Boeing's NGAD demonstrator and the projected timelines for the F-47 and F/A-XX programs signal a transformative moment in military aviation. The emphasis on production readiness, early integration of mission systems, and accelerated development cycles reflects a significant shift in defense contracting practices. However, stakeholders must remain vigilant regarding the potential risks associated with such rapid developments. By recognizing and addressing these nuanced aspects, military leaders and industry players can better navigate the complexities of modern military aviation and ensure that they are prepared for the challenges of tomorrow's operational environments. 1. Rapid development timeline. The transition of Boeing's NGAD demonstrator from contract award to its first flight in under 2 years marks a significant shift in the military aviation sector. This rapid development mirrors the timeline seen with the B-21 Raider and indicates a broader trend towards expedited production cycles in defense projects. The expectation that the F-47 and F/A-XX can similarly achieve rollout in less than 3 years demonstrates an aggressive commitment to advancing military capabilities at an unprecedented pace. This rapid timeline challenges traditional norms in defense contracting, where projects often face lengthy delays, and suggests a new paradigm for how military aircraft are developed and brought to operational status. 2. Emphasis on production readiness. A noteworthy aspect of the NGAD and B-21 programs is the intention to produce aircraft that are highly representative of their production models rather than mere prototypes. The construction of the first B-21 test article using the same manufacturing processes and tooling intended for the broader fleet exemplifies a commitment to quality and operational readiness from the outset. This focus on production readiness signifies a shift in how defense contractors approach design and manufacturing, prioritizing the delivery of functional operational systems that can be deployed effectively in combat scenarios, rather than relying on iterative prototypes that require extensive development before entering service. 3. Integration of primary mission systems. The inclusion of primary mission systems in the B-21 demonstrator indicates a significant advancement in the development of military aircraft. By integrating these systems at an early stage, Boeing is ensuring that the aircraft is not only built for speed and efficiency but also equipped with the capabilities necessary to fulfill its operational roles. This approach contrasts with previous practices where mission systems were often retrofitted into aircraft later in the development process, potentially leading to delays and increased costs. The early integration of mission systems in the NGAD and B-21 programs highlights a strategic focus on operational effectiveness and mission readiness, which will be critical as military needs become more complex and dynamic. 4. Future implications for military airpower. The advancements seen in the NGAD and B-21 programs signal a transformative period for military airpower. The expectation that future projects will adhere to similar rapid development and production-ready principles suggests that military forces may soon have access to advanced capabilities much faster than before. This shift could reshape the competitive landscape in military aviation as nations strive to keep pace with rapidly evolving threats and technological advancements. Furthermore, the emphasis on operationally relevant systems developed in compressed timelines could lead to a more agile and responsive military force better equipped to adapt to changing strategic environments. This evolution in military aviation development could have profound implications for how airpower is projected and utilized in future conflicts. 1. Lockheed Martin's F-22 Raptor development. The F-22 Raptor, an advanced tactical fighter developed by Lockheed Martin, showcases rapid prototyping and production efficiency. The program was initiated in the late 1980s and the first flight occurred in 1997, less than a decade after the contract was awarded. Notably, the F-22 was designed as a production representative aircraft from the outset, with an emphasis on integrating advanced technologies for stealth speed and agility. This approach allowed the U.S. Air Force to field an operationally capable aircraft relatively quickly, setting a precedent for future defense projects. 2. Northrop Grumman's B-2 Spirit. The B-2 Spirit stealth bomber developed by Northrop Grumman is another example of a rapid development cycle in military aviation. The program officially began in 1979 and the first flight took place in 1989, showcasing a commitment to operational readiness and advanced manufacturing techniques. The B-2 was built with a focus on low observable technology, allowing it to penetrate heavily defended airspace. The integration of production-ready components and systems during its development phase facilitated a quicker transition into service, paralleling the current trends seen with the B-21 Raider and other next-generation aircraft. 3. Dassault's Rafale. The Rafale, developed by Dassault Aviation, is a multi-role fighter that exemplifies quick development and production cycles in European defense. The program began in the early 1980s, with the first flight occurring in 1986. The Rafale was designed with an emphasis on versatility and operational capability, integrating various mission systems from the start. Its development featured close collaboration with the French government, allowing for a streamlined process that resulted in a production-ready aircraft within a relatively short timeframe. This approach mirrors the ongoing efforts in developing the F-47 and F/A-XX, emphasizing operational readiness over mere prototyping. The future of military aviation is poised for rapid transformation, particularly through the advancements being made by Boeing's next-generation air dominance NGAD program and the B-21 Raider initiative. The swift transition from contract award to first flight in less than 2 years for the NGAD demonstrator sets a significant precedent. This suggests that the U.S. military is increasingly prioritizing speed, efficiency, and operational readiness in aircraft development. Key predictions for the future. 1. Accelerated development cycles. The timeline for the engineering, manufacturing, development (EMD) phases of the F-47 and F/A-XX aircraft is projected to be less than 3 years, much like the B-21. This acceleration reflects a fundamental shift in how defense contractors and military programs approach aircraft design and production. By streamlining processes and integrating advanced manufacturing techniques, we can expect a significant reduction in the time required for new military aircraft to transition from concept to operational status. 2. Emphasis on production readiness. Both the F-47 and F/A-XX programs are expected to produce aircraft that are not just prototypes but fully production representative models. This approach minimizes the gap between testing and actual deployment, allowing for faster integration into operational fleets. The rigorous production processes applied to the B-21, which ensure that test articles are built with the same standards as production models, will likely be replicated in future programs. 3. Integration of advanced technologies. The incorporation of advanced technologies such as artificial intelligence, autonomous systems, and stealth capabilities will play a critical role in shaping the capabilities of the F-47 and F/A-XX. As these programs move forward, we can anticipate a focus on integrating cutting-edge mission systems from the outset, enhancing operational effectiveness and survivability in contested environments. 4. Enhanced collaboration and partnerships. The future of military aviation will likely see increased collaboration between defense contractors and government agencies. The success of rapid development cycles will depend on agile partnerships that can adapt to changing requirements and challenges. This collaborative approach will foster innovation and accelerate the delivery of advanced capabilities to the military. 5. Impact on global military balance. The rapid development and deployment of next-generation aircraft like the F-47 and F/A-XX will have significant implications for global military balance. As the U.S. introduces these advanced systems, potential adversaries may accelerate their own military modernization efforts, leading to an arms race in air superiority technologies. This dynamic will necessitate ongoing investment in research and development to maintain a competitive edge. 6. Shift in military strategy. The operational capabilities provided by the next-generation aircraft will influence military strategy and operational planning. The ability to conduct operations with advanced stealth speed and agility will allow for new tactical approaches in both offensive and defensive scenarios. This could lead to a rethinking of force structures and deployment strategies as the U.S. adapts to the capabilities of its new platforms. 7. Long-term sustainability and upgrades. As these aircraft are developed, there will be a strong focus on ensuring their long-term sustainability. This includes designing systems that can easily incorporate upgrades and modifications as technology evolves. The lifecycle management of these aircraft will be crucial to maintaining their relevance and effectiveness over time. Conclusion. In summary, the future of military aviation is on the brink of a significant transformation driven by the rapid development of next-generation aircraft like Boeing's F-47 and F/A-XX. With a focus on accelerated timelines, production readiness, advanced technologies, and strategic collaboration, the defense industry is setting new benchmarks for operational capability. As these programs progress, they will not only redefine air power but also influence global military dynamics for years to come. The emphasis on fast-tracked innovation and operational effectiveness will likely reshape how modern militaries prepare for and engage in combat, underscoring the importance of adaptability in an ever-changing security landscape.